Dear students, in previous lecture we discussed that if we have two one functions, that is if we have two injective functions, then their composition is also injective. That is, if f and g are two one functions, then fog or the GOF is also one. Now today we are going to discuss that if we have two onto functions, that is, if f from a to b is the function, and g from b to c is another function, such that these are surjective or onto functions, then we have to prove that this GOF is onto, because here we can only define GOF. Here GOF is the function from a to c. We have to prove that this GOF is onto, that is, for each and every element in c is the image element. That is, we have to prove that for z belongs to c, there exists a belongs to this, x belongs to this a, such that GOF of x is z. GOF of x is z. This means that any element or each and every element in C is the image element. This means onto function. Now it is given that f is onto, so this means that there exists y in b, because codomain of f is this b, such that there exists for this y, there exists x belongs to a, such that f of x equals to y. Name it first. Also g is the function from b to c and is onto because it is given. So for all z belongs to c, or for z belongs to c arbitrary element in C, there exists y belongs to b, such that g of y equals to z, because it is given that f as well as g is or onto functions. Now here, but y equals to this, from first y equals to f of x, it is g of f of x equals to z, which implies that, but g of f of x is actually, the this composition of two functions. It is g f of x equals to z. Hence, for all, or there, for each and every z belongs to codomain of GOF, that is, belongs to this codomain of GOF, that is C, there exists x belongs to this A, such that GOF of x equals to z. Hence, by the definition of this onto function, this function is also onto function. So we can say that if we have two one functions, then their composition is also one. Now if we have two onto functions, then their composition is also onto function. So from these two we can say that if we have two bijective functions, that is one onto functions, then the composition is also bijective function, because we proved that when one composition is one, when we have two onto functions, composition is onto function. Hence, from these two remarks, or from these two theorems, this GOF or fog is onto function. Now if we consider, the converse statement of these two. Now if we consider for first, if GOF is 1 GOF is 1 that is, GOF is 1, then what can we say about these f and g? Or these two functions again 1. Now let me consider an example, f from 1 2 3 4 to 1 2 3 4 5 6, that f is a function from this set to this, defined by f of x equals to x, f of x equals to x, that is, f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 4. So clearly this function is not 1. This function is not onto, this function is not onto, because in codomain range not equals to codomain, because 5 and 6 are not the image elements for any element of this 1 2 3 4 set. Now similarly, if we consider a function g from 1 to 6 to 1 2 3 4 5 6, defined by g of x equals to x, then clearly g is defined by g of x equals to x for all x equals to 1 2 3 4, and g of 5 equals to 5, g of 6 equals to 6. Clearly this function is also not onto, because 6 is not the image of any element from 1 to 6 from this set, that is, from 1 to 6. This function is also not 1 because we have two different elements of this domain, 1 2 3 4 5 6, which is 5 and 6, which are mapped with the single element. That is why this function is neither 1 1 nor onto, but this f is 1 1 but not onto. Here we can define, the for this graph. So graph is a function from 1 2 3 4 to 1 2 3 4 5 6, defined by g of f of x equals to g of f of x, which is, now f of x is x for all x belongs to 1 2 3 4, which implies that it is simply g of x, but g of x for this set for 1 2 3 4 is defined by g of x equals to x, so it is simply x, which implies that g of f is 1 1 function, but g is not 1 1. So we conclude we have this graph is 1 1. It does not imply as in general that g is 1 1 or f is 1 1, but it only implies that if graph is 1 1 implies that, the second function, which is f, this should be 1 1. Now similarly we can say that for onto, if graph is onto, that is composition of 2 is onto, it implies not in general that both are onto functions, but it only implies that the first one is onto function. So whenever graph is onto, it implies that the first function, that is g, is onto. If we have this graph as 1 1 function, it implies that the second function, that is f, is 1 1 function. Now if we consider, a non-empty set, that is set A, such that f from A to A is defined by f of x equals to x for all x belongs to A. That is, we consider, the function from set A to A as identity function. Then here we can, define, f of f, that is, we can only define f of f, that is composition of these two individual functions, that is f of f. So f of f is again identity function. It is again identity function. Identity function is 1 1 function. Identity function is onto function. So whenever this f of f is this onto function, it implies that both are, the onto functions both are 1 1 functions. So inshallah in tomorrow's lecture we will discuss, the inverse of a function, how to find, the inverse of a function. So thank you.